Hello, let's do more neural net programming. Alright, so this is going to be a continuation stream, or this stream is going to be continuing on my neural net programming and testing from this morning, trying to optimize the evolution with some sort of genetic algorithm. So, let's begin. So before right here, we have a neural net that evolves to a loss of under 1%, 0.3%, in 10 million iterations, which is 0.6 of a second, for a single neuron network, or it has two neurons with three connections. That's not that great, but I think it's actually better as you get more because you can do SSE and AVX stuff or optimization, so it's alright. But we're going to try to do it in less iterations by improving how we train it. Or not how we train it, how we... So we tried reducing, before we worked on reducing the training iterations, using stuff like R1 point sampling, and finding a good training rate. 0.2 works very well. So now we're going to try to improve the generation iterations by doing some sort of genetic evolution. So that's what we'll code right here. But I'll be right back. I'm going to make sure my cat that just jumped down has food. Then I'll be back. You know, I was looking at Visual Studio's color styling, and I still think that I can find a better font styling for gedit. I think I might do that. Alright, so here's a GitHub that has a bunch of gedit themes. I don't know if this has Regime Twilight. I don't know if this has the one I was looking for. Dark Mate. This one might be good. Vim. Monokai. I kind of like the look of Dark Mate, so that one was right here. I just gotta remember, where do you save the Gedit themes? Ah, here we go. GTK Source View 3 styles. Contact the administrator to gain permission to save there. I hate Windows 10. I am the administrator. Ah, you fucking stupid. See, on Linux here, it would ask me to enter the admin password to get access. Jesus Christ, Windows 10 is such a fucking mess. How is software QA going down the toilet so bad? It's so fucking horrible. Alright. Let's try it out. Oh, I could have selected the location, I think. Oops. Accidentally closed everything. Dark Mate. That one actually, I think it does look better. Oh, this has way more. So, if only there was an easier way to do this. Save to my desktop for ease, though. That's really dark. Vitamins. Try Zenburn. Oh my god, these are really bad. They're like really low contrast. At least they're bad for me. Oh, thank God. These are really bad styles. Maybe Stone Ship. Rails casts black improved. Try this one. Oh, that looks really similar to. Very similar. I am just gonna stick with the Black Pearl. That still seems really easy to read. All right. Well, that was a good waste of time. Hold on, let me just delete this. Okay. Genetic Evolve. So, I probably want a pool of neural nets. What is it called? Diversity, population. I'll just store the best. So I'm going to need to go into the neuralnet code here and make a neuralnet copy function that copies the weights and biases. Actually, I'm just going to program it. I wonder, since the biases and weights are all in one structure, maybe actually I can do... Maybe I can do this in one mem copy call. I just need to calculate this. Alright, there we go. That copies the neural net weights and biases. So then when we have a new best neural net, we'll copy that in there. Actually, I probably want to store the best loss as well. Alright, so we will copy. Oh, I also need to initialize the best neural net right here. I'll do new. Oh yeah, first I should actually check. Because it only does this with the genetic evolution model. Alright, there we go. Alright, so then I also am going to set the best loss to the min loss. There we go. Now it's going to randomly... Alright, so I'm going to try a bunch of different ways of doing this genetic evolution. The first one is I think I'm just going to mix these random values with the values of the best network randomly, basically mutating it based off of how much loss it has. So the higher error, the higher mutation. Loss could just be thought of as like stress then. Alright, so I don't just need the bias and the weight of this neural network. I also need the bias of the best, the weight of the best, so here I'm going to need to lerp. I think I already have a lerp function right here. Oh hell yeah, I have a lerp function. Alright, so we're gonna lerp between this and the best bias based on another random float that is from 0 to the best loss, which is clamped at 1. And do the same for the weight. Okay, here we go. So now this is lerping between the neural networks weight, the best neural networks we've found weights It's lerping between those randomly based off of how much error it has. So as it gets more accurate, it'll mutate less and less with the random values here. So hopefully that should speed up the training. We'll see. Let's see if this even compiles. Redefinition. Wait, where's that a redefinition? Oh my god, I was supposed to comment that out. Oops. Oh wait. Yeah, this is probably the easiest way to do that. Oh, yeah, so best isn't a pointer here. Oh, yeah. Okay. This music is awesome, so I'm going to turn it up. Oops, I did a capital letter where there's no capital. Alright. It completely failed. 44% error. Oh, man. 44% on average error. I don't think it's the lerp function. I actually don't know where the bug is. I guess if I knew where it was, it wouldn't be a bug. I think it's something with the lerping with the random values. Maybe I should output the neuralnet at the end of this. So these are the neuralnet weights and biases. Oh, holy shit, it trained to like 100% accuracy. What the hell? Oh my god. So sometimes it works way better than before. super accurate. 1.788E, negative 0.006%. Oh my god, that's such good loss. So that's the amount of error. So if it's 0 error, that means it's 100% accurate. So it's very close to 0 now, which is amazing. But the one question is, what the hell is happening right here? Ind. C float. Oh, so it's infinite. The result, a negative number, too large to store. Oh, so it's a negative number. Something is getting too large here. I don't think it's the best loss being fed in. Maybe it's oh. It's probably because I'm not initializing this. So I'm just going to initialize all the floats of this with 0 to begin. Because I'm actually not initializing the memory here, which would completely explain why some of this is showing up as null. Yeah, so now, oh my god, it's working every time way better than before. So how good is this now? Can I lower the generation iterations to like 100? Oh my god, it's doing amazing! 4E negative 0.006% accuracy at only 100,000 iterations, which is done in 11 milliseconds. 1/100th of a second. Oh man. And look at how perfect it is. So if I output the triangle wave right now, these are basically the exact values of the triangle wave at these discrete points. Holy shit! I've done this before and it's never worked this well. What did I do different now? Huh. So, brute force, 3%, 2%, 1%, 2%, 0.8%, 2%. Then with the genetic evolution, mutating the genes from the best neural net, 0.0003%. Oh my god. I'm moving on to the next tests now. I did not think it would work this well. And it's kind of consistent, 27%. It's still inherently random. Realistically, you can just get unlucky sometimes, and it's just not going to train at all. You're going to get the 27% or however much error it is. But oh my god, it's working so well most of the time. Like, the majority of the time. Alright, so the next test I'm going to move on to is generating text. A recurrent neural network generating a sequence of characters or letters. So, yeah, that's going to be a harder test to set up. Alright, so test text sequence. Alright, I should probably have a fixed sequence I don't know if I want to take something from a dictionary, or maybe I could just take some code. Could always take some code. I'll write something. What macro do I have for this again? I have something for declaring C strings with their length as a constant with it. C string. There we go. Sample text sequence. Hello world, I am. I'll do this non-caps. Hello world, I am a neural network. Generating a text sequence. So we're going to do one-hot encoding for this. I just want to see one-hot encoding alternatives. I haven't looked. Maybe there's better ways. One-hot encoding alternatives for large categorical values. One option is to match rare values to other. This is commonly done in natural language processing, the intuition being that very rare labels don't carry much statistical power. I've also seen people map one-hot categorical values to lower dimensional vectors, where one each hot vector is represented as a draw from a multivariate Gaussians. Oh, that's a really good idea. So as the classes get more, that's actually really complicated to do, how you would even rank what rare is, because at some point things can change, like how rare something is. I guess if you have all your data at the beginning, I'm just going to do one-hot encoding. So one-hot encoding is where you have one neuron for each letter. Alright. So that's our triangle wave test. We are now going to do the text sequence test. It's going to start out just like the other one. It's going to initialize the neural network at neural state. I don't know. It's going to be hard to measure min loss and all that, but we can do it. Alright, so this is an interesting one too, because this would actually probably be a good point to use a sign activation function or something of the sort. Sigmoid. I have a very big feeling that that would work very well. Text processing, but I'm going to start with just the linear activation to begin. Alright, so first of all, we actually have to analyze our text sequence to do the one-hot encoding. We need to analyze how many letters are in this. We need to map the letters to neurons. So what we're going to do is we're going to create a list. Called text letters. Oh yeah, and I'm just going to initialize it here. So it's just going to store characters as letters. So I don't have to search this up. I'm actually going to do this in a lookup table, so I don't use a list, because that would be, it's like, why not? It's only going to use like 512 bytes, so letter to neuron. And then letter list. Alright, there we go. So to initialize, it's going to set this to 255. 255 is going to say that we don't have any letter assigned there, and it's going to assume that we're never going to use all 255 characters. So now we're going to loop through our text. We're going to get the character from that. We're going to check that's currently contained in the list. If it's not, we're going to add it to the list. So now this gives us a lookup table to convert our letters in the text, the ASCII characters, to neuron indexes. So this is also the number of input and output neurons we have, plus the amount of memory we want with this model. So that's going to be a complicated amount thing. I'm just going to go get more water in a second. So I think I'm going to output sample text sequence and output that using letter, this number of letters. All right. So I probably want the number of hidden neurons to be based off that, but we'll see. I'm gonna try no hidden neurons to begin, just for fun. I'm curious. Yeah, so then the amount of memory I want as well. I guess I'll define this here. So I'm going to give it 10 memory to begin. So the neural net memory is passed from the output back to the input. And then, yeah. So it is complicated. And then this neural net is just going to copy the other one. And here, when it sets them all to 0, need to calculate the total size. How would I do that? I'll just add them all up here.
Footsteps farther down the road, black out, a night that paints in cold.
Alright. That initializes the neural net state. I'm not going to store test values there. Alright. So now we're going to do the actual loop. It's still very similar. Alright, I'm gonna go get more water. My throat is getting sore. It sucks. So, yeah, we're not gonna use, we can't use R1 point sampling here. We're just gonna loop through each character. I guess we can just use T. But yeah, I'll do that once I get water. I'll be right back.
Whispers that bathe themselves in gin to the brim, till the old road is flooded. Promises burn. I hold no cross and I pay no toll. Race with my wheels on fire to a place far beyond the drop-down sky. Possible to find. Step into the light.
Alright. So this T value gives us our text index. We're going to input to the network.
Step into the light.
We're going to need an initial neural net state, I think, as well. It's going to copy the input to the output. So I'm going to create a function of set floats. Yeah, so I guess I'll copy the output each time. Or maybe I'll copy it to the input after. So this initializes the memory to 0. So now this will give us our sample character. That is our goal. Yeah, so I don't know if I want to so I have the option of automatically inputting the last character. I don't know if I want to do that or just have the memory. Like I might just have the memory and then have a lot more memory. Neuralnet handle it itself. So I might set the first memory value to 1. We'll try both ways. So anyways, the only input is the memory. So we just run the neural net forward here. Now we have to sample the output. Oh, I figured it out. So because it's random which thing is actually output, that's why you need to output the input. Or input the output. Oh, okay. So I got it. See, I do need to do it like this. I haven't written one of these recurrent text generators for a while. And this actually isn't the normal recurrent neural net model. This is a stupid kind that I'm making. But I think the simple kind will work better with the brute force evolution. We'll see. Yeah, so the first input will actually always be the first character of the text. Yeah, so I'm actually going to need to set this each time this iteration resets. I probably just want to input the letter, yeah, okay, so the sample index is the modulo of the size of the text sequence. Then if that is 0, we reset the memory because we're restarting. So yeah, then I'm also going to need to set this all to 0. After each one. Otherwise, right here, alright, there we go. So that inputs the last letter. So then we run that forward. Then to get the result, we need to sample the 1-hot encoding probabilities. So I believe I have, it might be in VecMath, it might not have a function for sampling the probabilities. Or actually, it's probably an RNG. If I had to guess, I put it in RNG. Yes, okay, using real probabilities P. Here we go. So RNG ID. Actually, I probably should input the actual last one. Alright, I'll actually store the last character to do that, just it will work better. Right, so after doing it forward, get the character ID. So then close up these other files. Probability and the length. So our probabilities is the neuralnet outputs here. This is the first part of that. So there we go, that's the last character. Alright, so now to train it, we need to train it towards the character that it should have been and calculate the law. Yeah, so I'm actually not going to have this last part. I'm going to do that out here. So average loss is going to be the sum of loss over these. So each one of this is going to reset. And the last loss, L loss, is going to be the last actual full loss calculated. Hold on. Oh man. All right. Okay, so the loss is actually going to be the difference between all these. Not the selected character, but the difference between the values and the targets. So I have to loop through all of them, I believe. Yeah, and oh man. So I don't think there's actually going to be any training for the memories unless I do back propagation. Unless I just do random training for the memories, but that's just like evolution. So this is going to be the real challenge, I'm guessing. It's figuring out how to do effective back propagation for training the memories. Because back propagation through time takes up giant amounts of space in memory, especially once you get big neural nets. I'm really looking for something like this that just works with evolution. Anyways, let's try it. So we'll get the target character from our sample text sequence. So all of them are going to be negative except for this one, which is going to subtract. If I equals target character, actually I should just do that differently. How am I going to do this to start? Alright. So that trains all of them to 0. Now I need to set the one to target to 1. I don't know how to do that without an if statement here. Whatever. I'm just going to do it the slow way. Doing an if statement each time. Not really focusing on performance yet. Alright, then train. Oh yeah, then actually I also need to set all of them after that. I need to set all the memory to 0 because those aren't being trained. And I should actually I should add a thing here that goes if error equals 0, continue and skip. That will improve performance. Alright, let me do neuralnet train. There we go. So then if that loss is smaller than the min loss, we'll copy the best model over. And what I'm also thinking I should do is maybe generate with the best network at the end a little text sample. Yeah, so here I'm going to run the neural net to generate a sample. So I'm going to need to reset the state for this. Alright, then I'm going to do the generation loop of 50 characters. So I don't think our sample sequence, that's like double our sample sequence, so that should give us a bit of room for, I can't remember what it's called when the neural net fills in the gaps. Oh, this is actually supposed to be plus. Oh, I forgot to copy the memory over here. Alright, so after this I'm supposed to copy the memory over. Forward propagation, I'll copy it over. Alright, there we go. That copies the memory over. Now I can do that right here as well. Alright, let's see if this works. Size of sample text sequence undeclared. Alright, let's try it. Min loss 0%. That's definitely wrong. Sample text sequence, hello world. I'm a neural network generating a text sequence. 20 letters. How long is that? Minimum loss of 0. Oh, it must... I'm not adding up the loss yet, am I? No, I was not adding up the loss. I should have expected it. Hey, said who? Alright, then I gotta add this loss to there. And then I need to divide by the number. So this one I need to divide by the letter list length. What's up? I'm testing neural network stuff, trying to make a neural net generate text, sequence of text, without doing the normal recurrent memory model. Instead, I'm trying to just pass the input back to the output and use evolution to train. So the craziest thing ever in a GTA RP stream. Really? What was it? And then the A loss right here I need to do divided by size of sample text sequence -1 to make it averaged by the number of samples. Okay, see how that works. Now convert from float to float. Oh. H Q Q Q H H H H H H H H G H H H H H. It says it trained to negative 0.0008%, but some guy proposed to his girlfriend. He had just used her as a hostage earlier for robbing a bank. Min loss. I'm doing something wrong with the loss right here that's calculating it so low. Oh, the last character is wrong. It's really funny. I'll send the timestamp. Alright. So I think I'm using the last character wrong here. Yes, I don't even need to randomly generate this here. I don't think so, at least. Instead, I can just do like this. Why is it taking so long to execute at the end? I mean, oh man, what is that? It's not generating this, I think. Don't want to spoil it, but at that point they were pretending to be mad at her and to take her hostage again. So they stole her shit and gave her to police. Ah. Neuralnet really likes outputting the letter H. Oh, this is supposed to be +1. So it's training to be the last character. Oh. Ha. Ha. That's a very long drama. You'll need to have watched the whole stream. Yeah, I feel like you need to really watch the GTA role playing to get into the characters. Yeah, so that's way too low loss for what this is. It's getting every character wrong. I wonder if that's just my RNG ID messing up. Maybe my RNG ID function is wrong. Or maybe I should do max difference here. Anyway, it was beautiful. Nice. Maybe I shouldn't divide by this. Let me see what loss I get like this. Yeah, that's still way too low. Why is it lag right at the end? Can I give you small advice? Sure. Is my audio too loud? Yeah, that didn't help at all. ++I is better than I++. Is it? I just expect the compiler to optimize small things like that, especially the C compiler. Yeah, why is the loss so low? Maybe if I do max loss. No, still way too low. Man, what is that delay? Why is there a delay right at the end of executing it? It didn't even shoot up to top CPU usage. What the hell? I don't understand. I think some memory is definitely getting overwritten or something because or maybe it's this part here I added. Doesn't add the weights or values property, maybe we'll see. Min loss 0%. Oh shit, yeah, there's something definitely wrong. Hold on, I'll be right back. Alright. Yeah, so it's giving 0 loss each time, even though it's horrible, and whatever's freezing it at the end right here, I don't know. I'm going to take away the sampling because it might be what's freezing it. I think the freezing only started after. No. That wasn't it. Okay. Alright, something about the training right here. Yeah, man, I'll watch it later. I'm just concentrating right now. Gonna take away the training. I think it might be the mem copy. Good luck, thank you. Oh, it's still freezing. So then, just for reference, the triangle wave test doesn't freeze after execution. I don't believe. Yeah, no, it's instant. So there's something with this. This is probably going to be obvious, but if I comment this out, it takes away the delay, right? Yeah, it does. So it's not this that's delaying it. Let me check if this adds the delay too. Yes, it does. Oh, and right at the beginning here, it's very random. Wow. Wow. Even without training, that looks fairly realistic. Or not realistic, but it's gibberish, but it's generating actual text sequences, which is still a lot better than repeating the exact same letter. So I'm gonna gradually enable and disable the parts of the code till I find out the part that causes the delay. Alright. So just running this causes a delay. So what part of this is it? Is it the neural net forward propagation? No, it is not. Is it the mem copy? I'm guessing the mem copy is going over onto the stack and it's messing it up, the return. No, not that. RNGID? No, not that. SetFS. None of those, but if I comment this out, wait. So it's still delayed? Even without executing that. Oh my god, so it's something right here. Maybe one of these. Eventually I'm gonna get figured out. I think it's the setFS right here, if I had to guess. I'm thinking I'm going to comment this out right now, and it's going to run with no delay at the end. Yep, no delay. It is the setFS. I knew it. Alright, so what is it about the setFS? Input state plus letter list length. Size neural net memory. So if I comment these out, does it work? No, it still has the delay. That's so weird. There's still another part causing the delay. Oh, it's this mem copy. Yeah, so something about writing past the letter list length. Let me check out where I create this neural state. I might have done too many here. No, it's good. Alright, I gotta figure out what it is about this that it's overwriting. Alright, let me debug this. Seventy 070. Yeah, that's correct. I don't think it's something will set FS, is it? No. It's definitely writing too much. But why is it writing too much? Is it not allocating enough memory? Neural net state? Yeah, it's almost like the state. Oh my god, I'm not multiplying by 4. They are floats, and I'm not multiplying by 4. God damn. There we go. Well, my issue was I just wasn't allocating enough memory. I'm a dumbass. There we go. Randomly generates the text. Now let's try the training. See if the loss isn't 0. Yeah, the loss is still 0. So something is still wrong with the training here. And it has a delay. Oh no, actually it's ending properly. Good. So let me break this down. How many training iterations are there? 1,000. Good. So t modulo iterations. Set this to 0. We can initialize the last letter as input. At the beginning, initialize the memory as 0. Initialize the average loss as 0 for adding it up. Take the last average loss, it's the L loss, which is of course divided by the number of samples to get the average. Forward propagate that state. Copy the memory over from the output layer to the input layer. Get the target character. This is supposed to be the letter to neuron. Oh, this is supposed to... This is doing max too, which is crazy. This should be well above 0. And the average loss adds that loss. Oh, it's defined by the letter list length. Loss plus equals. Yeah, so this is really weird how it ends up being ends up being 0. L loss smaller than min loss equals L loss. Ah, min loss is 100%. That's more like it. That's how it's supposed to be. And it just does H every single time. I am recalculating this, right? Yeah. I think this is actually training way too fast. I'm going to take the training away. Oh no. So I need to actually do... Wait, that should have worked. The loss should be less than 1e9. Iterations. The length of 60. So it'll go the first training iteration, it'll reset this. Then so if it's doing 60 iterations, the last one will be 59. So 59, size of sample sequence minus 1, which is 59. Mod 59 mod 59 will be 0. So then this will be 0, and this will do a loss divided by the sample text sequence length minus 1, which should give us the loss, unless this is actually 1e9 right here. If this is actually 1e9, oh my god, let me calculate that. If a loss bigger than 2, I don't think it is, but oh my god, it's infinite. Okay, yeah, never mind, there's something definitely going wrong. That would explain a lot. If is not a number or not is finite. How many times is this going to infinity or not a number? Oh god, that's a lot of times. Seems to be normally near the end, like 40. So interesting. Maybe it's the training. Oh, I know what it is. These outputs need to be clamped. If the outputs aren't clamped, then it just keeps adding up through the memories. There we go. No more not a number. Alright, so then instead of max loss, I'm going to do average loss. Why's the loss negative? Why is it negative? What did I do? Oh, it's supposed to be absolute. I feel like I need to normalize the difference since it's probabilities. Because I mean, like, it's sampling the probabilities, so that's not going to exactly give a good result. And maybe it will. Try adding a little bit of a learning rate. Alright, so I'm going to take away genetic evolution. I'm just going to do brute force evolution. With no training. And then we're just going to do a heck of a lot of generation iterations. We're going to see how good this gets. I don't think it'll be that good because it actually doesn't have any hidden layers yet or any hidden neurons. And it's also, there's a good amount of neurons now. I should actually look at doing SSE and AVX to speed this up, because it's not that hard to implement, and it would speed this up 2.5 to 5 times, which is really good. I might have done too many iterations. Maybe. Best one had 15%. Yeah, so this isn't a good way of measuring the difference. At least I think it isn't. Because, like, it doesn't actually tell. It's not, oh man. Just averaging the difference doesn't actually say whether or not you're getting the right characters. Hey, Sin. How are you doing? How's the Chronic Cast chat doing? I mean, I may as well just keep running this while I'm thinking about it. Chronic seems to be doing great. Yeah, I'm doing good too. I am just really, man, I'm trying to figure out this math for training a recurrent neural network. It is really complicated. Like, I don't even know how to judge if it's doing well. Because the issue is the characters it outputs are relative to each other. So I can't just compare it to a set output. I need to compare them to each other as well. Oh man, didn't know you were a programmer until I saw in Chronic. Yeah. It's like my favorite thing. I know Keith is starting back up school for it. I'm interested to see where he goes with that. It's really good at outputting gibberish. Finished my bachelor in Jan. Nice. Yeah, it's something you really need to keep practicing. Yeah, so I think actually instead of just taking the average, I can normalize this and calculate the total. And then instead of averaging by the count, I can average by the total. To get back to programming, or just gonna find a job in the field and start working with photography, front end now. Photography is really cool. I have people in my family who have sold a few, or they've went and sold prints for a few photos they've taken. But yeah, also there's so many different fields for programming, it can be very hard to pick which one you want to do. And then you also don't want to focus in too much on one category because it changes so much so quickly. Right, so I'm going to total this. Wait. Okay, so actually I can do... and sum it like this. And then here I can then divide it by the sum. Alright. And then I also need to check if the sum is 0, because if not, it'll be not a number. Let's see if this works better. Do a lot of printing though at the company, but I also work as tech support because people ask me all the kind of questions out of the photography field, so I guess my education wasn't wasted. That's true, it also applies to basically everything else now, because everything uses computers. Alright, I'm not gonna wait for this. I'm just gonna lower the iteration so it works instantly. Oh, okay, now it's definitely broken. 0% loss, but it's still gibberish. Oh, if sum equals 0, that's supposed to be if sum does not equal 0. Oh, there we go. 95% loss. That's a lot more accurate. Yeah, that's actually really good. So this gibberish right here is the text the neural net's generating this sample text sequence, hello world, I'm a neural net, is what I'm trying to test. So before it was telling me it was like me just calculating the average error was telling me it was 15% off. So doing the normalization here is key. Alright, so now I'm going to boost up the training. And I'm going to see if training it will really help it improve. No. So that's the really difficult part as well, is with a recurrent neural net like this, if I want to actually train it and train it to form the memories, which is the whole recurrent part, it's the output of the neural net feeding back into the input to make a memory. To do that, I need to backpropagate the state, which is basically I need to save all of this text data all through when I generate it, and then once I get to the end, I need to calculate and propagate backwards through it, propagating the memories, and then I can train each of those backpropagated each time I backpropagate through it. And it's so much more expensive, it uses so much more memory, so that's why I'm really avoiding it, but I don't think there's going to be much avoiding it. Yeah, the other thing is, there's so many things to test with this. Like, besides just changing the learning rate and how much it trains, I can also, I'm not doing genetic evolution right now, so that might improve it. And then I can also change the bias and weight range, which is something I should actually be evolving. I should actually change the bias and weight range randomly and basically search to see which ones are working better. I'm still testing though, I'm not sure if training is even making it work any better. Oh yeah, it definitely is. Goes from like 90% to 70%. Yeah, so I'm curious now. I really wonder if I take away the memory, will it actually work better? $138% loss. Okay, something is actually wrong there. Oh yeah, it definitely doesn't work as well. Yeah, so the more memory, the better it does. I think. Just got worse. Never mind. So there's a certain point where it gets worse. Alright. I'm going to try and boost the bias and weight range. That's also going to make it train a lot worse, I believe. Actually, no, it's down to 60-70% now. It's interesting. Alright, let me try adding hidden layers now. Or hidden neurons. Where is it? Right here. How many is good to start? guess I'll just add 30. Oh my god, wait, 10%? 9%? 1%, but it's still completely off. Yeah, so I think my calculation is still off, I think. Because if it's 1 or 3% off, it shouldn't be this random, I think. What is up with this audio? Going like do do on and off. Alright. It's too much of a change. What to listen to? YouTube's got so much shit now. It used to just suggest so much good stuff. Alright, this might be good. Instrumental band from Sydney, Australia. Alright, so here, instead of running through this RNGID function, it samples the probabilities that the neural net outputs. Oh my god, there's just so many things I want to do for this. It's like, I'm also going to go and test doing max loss again, but then dividing by the max value, similar to this normalization, see if that works better. Yes, this, still need to test this though. This could just be messing up the probability sampling, and so I need to sample the max value. So just loop through the array. Check if the value is bigger than the current max, and then if it is, we set the last character to that. Alright. Oh my god, it actually is working. Hello WO ATET AAAAA. Oh my god, that's so interesting. H no Trata netet work geared at orata netet work gear. It starts repeating itself after a certain. Hello world, ILO, sequir, tetwar, 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 tet. Oh, it gets stuck in an infinite loop. Poor neural network. Oh, poor neural network. Hello world, nilo, world, nilo, world, nilo. Oh man, this is actually really good. It's actually generating it. It's just running out of memory. After this certain point, it doesn't have enough memory to continue or something like that. Huh. Yeah. Oh, so the memory probably doesn't evolve correctly. Oh, okay, I'm gonna be really curious in testing the limits of this. So, okay, I'm gonna try this without. Oh my god, so all of this, those could have been working before, I just wasn't sampling correctly. Okay, so this is with no hidden layer. It does not work well at all. It really needs the hidden layer to even hidden layer is the main core of the processing. So I'm going to do 10 hidden neurons to begin. I'm going to try only 4 memory neurons. Okay, I'm going to try ramping up the hidden neurons here. Here, G-Quidna, Senna. Sen. Hello, Gwext, Sequilo. It's so interesting. Hello, text. Yeah, so it definitely depends on the memory. That's so interesting. So we'll do 100 memory neurons and 100 hidden neurons, and it should be able to train. Hello world, I am a neural network. Te. Oh my god. Actually working. Axel and oh my god. I actually feel like some of these neural nets have mental illness or something, because Anoletoxin. Oh, poor neural net. I think my way of measuring the neural nets is still wrong as well. Hello world, I'm a neural net. I'm pretty happy with this. That's pretty cool. I'm probably going to end the stream here. Oh man, the next time I want to do this, I probably want to move on to doing the tic-tac-toe game as well. I want to try and get the neural nets playing tic-tac-toe, which is that's a big challenge actually. I think playing a game against each other, and then I'm going to use that to test adversarial networks. We're going to see how that works. It's going to be interesting. I'm going to try to get this text generation working a bit better, but yeah, that's going to be hard. I think I need to find a way to train the memory. I don't know. I think randomly generating these memory neurons isn't a good idea, because it's probably not evenly distributing them. Yeah. That's the thing, is how would it form the memories? I don't know. Anyways, that'll be something for one of the next streams. I'm definitely going to think about this off stream too, because this is one of the key things, is how you get the neural network to form its own memories without giving it a base framework to follow. But that'll all be really fun stuff to program. I hope everyone else enjoys neural net programming as much as I do. If you do, come and check out the stream again. I'm going to be doing more of these. If not, if you're interested in some of my gaming streams, I think I'm going to be streaming Fear Extraction Point tonight. I think I'm going to do the next part of Fear. So yeah, lots of stuff going on this channel. If not, check out the Discord. Talk on Discord. Man, this music is kind of low-key. Anyways, hope everyone has a good day. I'll see you all later.